Today we are going to learn about mastering NLTK POS tagging for text analysis. You will gain practical knowledge on implementing and optimizing POS tagging using NLTK, crucial for syntactic understanding in NLP tasks. Welcome to our video on mastering NLTK POS tagging for text analysis. In this tutorial, we will explore the fundamental concepts of part-of-speech tagging, a crucial task in natural language processing that assigns parts of speech to each word in a sentence. This skill is essential for tasks that require syntactic understanding, such as parsing and information extraction. We will focus on how to implement and optimize POS tagging using the Natural Language Toolkit, or NLTK, a popular Python library for NLP tasks. By the end of this video, you will have a comprehensive understanding of how to use NLTK's POS tagging capabilities effectively for various text analysis applications.
Part-of-speech tagging is the process of marking up a word in a text as corresponding to a particular part of speech, based on both its definition and its context. This is crucial for understanding the syntactic structure of sentences, which in turn is important for deeper linguistic analysis. POS tags include categories such as nouns, verbs, adjectives, adverbs, etc. For instance, in the sentence "The quick brown fox jumps over the lazy dog," each word can be tagged as a noun, verb, adjective, etc. This tagging helps in identifying the grammatical structure of the sentence, which can be used in various NLP applications such as parsing, machine translation, and sentiment analysis. Understanding the basic tags and their roles in sentence structure is the first step in mastering POS tagging.
The Natural Language Toolkit, or NLTK, is a powerful Python library that provides easy-to-use interfaces to over 50 corpora and lexical resources, including a robust POS tagger. NLTK's POS tagger is one of its most popular features, allowing users to automatically assign POS tags to words in a text. It uses a variety of algorithms and models to accurately tag words, including default taggers, regular expression taggers, anagram taggers, and more advanced techniques like hidden Markov models. NLTK's efficiency and ease of use make it an ideal choice for both beginners and advanced practitioners in NLP. Understanding how to leverage these tools effectively is key to optimizing text analysis tasks.
To utilize NLTK's POS tagging capabilities, it's essential to first download and access the necessary corpora. NLTK provides a vast array of corpora, which are large collections of text used to train and test NLP models. These corpora can be downloaded using the NLTK data downloader, and include popular datasets like the Brown corpus, the Gutenberg corpus, and many more. Once downloaded, these corpora can be used to train and test your POS tagger, ensuring it has a wide variety of contexts and sentence structures to learn from. Practical implementation involves writing Python scripts to load these corpora and apply POS tagging, providing hands-on experience with real-world data. One of the strengths of NLTK is its flexibility, allowing users to customize the POS tagger for specific domains. Different domains, such as legal, medical, or technical fields, have unique vocabularies and syntactic patterns. Customizing your POS tagger involves defining a custom tag set that is more suitable for the domain you're working in. This might include adding custom tags or modifying existing ones. Training custom models using domain-specific corpora can significantly improve the accuracy of your POS tagging. This customization is crucial for applications requiring high precision, such as legal document analysis or medical text processing. Understanding how to tailor NLTK's tools to your needs is key to maximizing their effectiveness in real-world applications. Ambiguity is a common challenge in POS tagging, as many words can serve multiple roles in a sentence depending on context. For instance, the word book can be a noun or a verb. NLTK tackles this challenge using statistical models that analyze the context of words to make informed tagging decisions. Techniques like n-gram models and hidden Markov models help in disambiguating words by considering the surrounding words and their tags. Improving accuracy involves training your models on diverse and extensive datasets, and fine-tuning parameters to better capture the nuances of language. Addressing ambiguity effectively can significantly enhance the performance of your POS tagging models, leading to more reliable text analysis.
Integrating POS tagging with Python scripts is a practical way to automate text analysis tasks. Start by familiarizing yourself with basic Python scripting, including reading and writing files, and handling text data. NLTK can be easily integrated into these scripts, allowing you to automate the process of POS tagging large datasets efficiently. This integration involves importing NLTK libraries, loading text data, applying the POS tagger, and processing the tag data for further analysis. By automating these tasks, you streamline your workflow and enhance the scalability of your text analysis projects. Practical Python code examples will demonstrate how to implement these steps, providing you with a robust foundation for integrating NLP tasks into your projects.
To achieve optimal results in POS tagging, it's important to follow best practices. Begin by selecting the most appropriate corpus for training your model, ensuring it represents the domain or language of interest. Model evaluation is crucial. Use metrics such as accuracy, precision, and recall to assess performance. Parameter tuning involves adjusting model parameters to improve accuracy and efficiency. Conducting error analysis helps identify common tagging errors, providing insights for model improvements. Finally, continuous learning and adaptation are essential in NLP, as language evolves over time. Staying updated with the latest research and techniques will ensure your POS tagging models remain effective and relevant.
POS tagging has numerous real-world applications across various NLP tasks. In sentiment analysis, it helps identify the sentiment conveyed by different parts of speech, enhancing the accuracy of sentiment classification. Information extraction relies on POS tagging to identify key entities and relationships within a text, facilitating data mining and knowledge discovery. Machine translation uses POS tags to maintain grammatical structure across languages, improving translation quality. In speech recognition, POS tagging aids in understanding and converting spoken language into coherent text. Text summarization benefits from POS tagging by identifying and retaining key pieces of information. These examples highlight the versatility and importance of POS tagging in modern NLP applications, demonstrating its value in diverse fields. In conclusion, mastering NLTK POS tagging for text analysis is an invaluable skill in the field of natural language processing. Throughout this video, we covered the fundamentals of POS tagging, explored NLTK's robust tagging capabilities, and examined practical applications across various domains. Understanding and implementing POS tagging enhances your ability to analyze and process text data effectively. As you continue your journey in NLP, remember the importance of continuous learning and practice. We encourage you to experiment with NLTK tools and apply your new skills to real-world projects. Thank you for joining us, and we look forward to seeing what you accomplish with your newfound knowledge.